Okay, hello everyone in a new video. So we have reached part 6 of chapter 5, which is the chapter of kinematics for grade 11 students. So in this part we are going to solve some exercises. Let's start by exercise number 16. The parametric equations of a moving particle m in an xy plane are given by. So number 1, they are telling me to write down the position vector. We know that r is equal to xi plus yj. This is a vectorial equation, so vectors must exist on the left and on the right. Now x is given by so this is the position vector of the moving particle. Now in number 2 they are telling me to determine the velocity vector. So in order to determine the velocity vector of this moving particle, knowing that we have the position vector, we need to discuss the type of motion along the x-axis and along the y-axis. So here on the scratch, let me recall the equations of motions regarding URM and UVRM, because the motion in 2 dimensions can be decomposed into two motions. Motions along the x-axis is said to be rectilinear motion, either URM or UVRM, and the same for the y-axis. Now here in this case URM, we have that x is equal to vt plus x0, v is equal to a constant, and the acceleration is equal to 0. Now in the case of UVRM, we have that a is equal to x is equal to half at squared plus v0t plus x0, v is equal to at plus v0, and the acceleration is equal to a constant. So, and another equation is given by v square f minus v square I is equal to ad, but this is not considered as an equation of motion, although it exists for the UVRM. Now, let's start by studying the motion along the x-axis. So notice that the position along the x is quadratic in time. Whenever the position is quadratic, this means that the type of motion is UVRM. Since x is equal to minus 5t squared minus 15t plus 20 verifies the general form, x is equal to half at squared plus v0t plus x0. Notice that here, because the motion occurs along two dimensions, so each component must be distinguished between the x and the y. This is related to the x, so it must carry the index x. Then the type of motion is UVRM along the x-axis, and in this case the following equations hold, that are given by x is equal to half axt squared plus v0xt plus x0, v is equal to at plus v0, and all of these quantities except for time must carry the index x, as well as that the acceleration along the x-axis is equal to a constant. Knowing that we are interested in determining the velocity vector, which is v is equal to vxi plus vyj, and this is done by determining vx and vy. So we are interested in determining vy, so we need to determine ax and v0x, and this is done by comparing it with the given form, which is equal to x minus 5t squared minus 15t plus 20. So we can safely say that by comparison, now comparing both quadratic terms, half ax is equal to minus 5, which means that ax is equal to minus 10. All quantities in physics must have unit. Notice that here everything is expressed in the SI, and eventually a of x will be expressed in meters per second squared. Now, it's left to determine, in order to determine v of x, it's left to determine v0x. So, and this is done by comparing the linear terms, and here we can see that v0x is equal to minus 15, and the SI unit of speed is given by meters per second. So in this case, the speed along the x-axis, which is the x component of the velocity, is given by minus 10t minus 15. Now we repeat the same discussion, but as for the motion along the y-axis. Now since y is given by minus 40 square plus 16t minus 30, notice that in this case the position along the y-axis is quadratic, which means it is UVRM. Then verifies the general form, which is given by y is equal to half at square plus v0t plus y0, and here the same, everything must carry the index y. Then the type of motion is UVRM along the y-axis, and in this case the general equations are given by y is equal to half ayt square plus v0yt plus y0, vy is equal to ayt plus v0y, and ay is equal to a constant, and the given form is given by y is equal to minus 40 square plus 16t minus 30. In order to determine v of y, we need to calculate a of y or v0 of, and v0 of y. So here let's say by comparison, now comparing the quadratic terms, we have half ay is equal to minus 40 minus 4, which means that ay is equal to minus 8 meters per second square. Now as for v0y, comparing the linear terms, we deduce that v0y is equal to 16 meters per second. Now in this case, vy is equal to minus 8t plus 16. Now after we have determined the x component and the y component of the velocity, so we can say that v is equal to minus 10t minus 15 I plus minus 8t plus 16 j. So this is the velocity vector v. For sure the unit of v in the SI is meters per second. Now in the same part they are telling me to deduce at any instant the speed of the particle, and we know that this velocity vector has four properties that are given by point of application, line of action, direction, and the magnitude. The magnitude is denoted by v, and v stands for speed. The magnitude of any vector is given by v is equal to square root of vx square plus vy square. So this is the square root of minus 10t minus 15 to the power 2 plus minus 8t plus 16 to the power 2. Then the speed is given by the square root of minus 10t minus 15 to the power 2 plus minus 8t plus 16 to the power 2. And this carries the unit meters per second. So notice that here inside the square root we can expand and reduce the following two quadratic equations, okay, or expressions. Now in number 3 they are telling me determine the acceleration vector the acceleration vector is given by A is equal to AXI plus AYJ. Now in order to determine A, we need to determine A of AX and AY. Now referring back to part 2, we can notice that A of X is given by minus tan and A of Y is given by minus 8. So, but we know that A of X is equal to minus 10 meters per second square and A of Y is equal to minus 8 meters per second square, and the acceleration vector A is given by now on the same part they are telling me to deduce at any instant t the magnitude of the acceleration. So this vector has four properties that are given by the point of application, line of action, direction, and magnitude. So the magnitude A is given by the square root of AX square plus AY square, and this holds for any vector. Then the magnitude of the acceleration is given by this, which is the square root of minus 10 to the power 2 plus minus 8 to the power 2. This is given by square root of 100 plus 64. Plugging this on the calculator, then it's given by 2 radical 41 meters per second square. So as you can see that here the acceleration is constant and independent of time. Now in number 4 they are telling me calculate at the instance t1 is equal to 2 seconds and t2 is equal to 5 seconds the speed and the magnitude of the acceleration. Let's start by the speed, or let's start at the instant t1 is equal to 2 seconds. Then v1, which corresponds for the speed computed at the time t1 is equal to, we are interested in determining the speed, right? Okay. 2 seconds. Now the expression of the speed is given by this one. Now instead of t we will replace 2 here, and instead of t we will replace 2 here. So it's given by the square root of minus 10 to minus 15 to the power 2 plus minus 8 to plus 16 to the power 2. Now plugging this on the calculator, then it's given by 35. Since everything is expressed in the SI, so the speed of the particle at the instant t1 corresponding for 2 seconds is given by 35 meters per second. Then v1 is equal to 35 meters per second. Now as for the acceleration a1 corresponding for the magnitude of the acceleration t1 is equal to 2 seconds. Notice that the acceleration is independent of time and it's constant all the time, so it's given by 2 radical 41 meter per second square. Now finally we need to compute the same quantities but at the instant t2 is equal to 5 seconds. So v2 corresponding for v at the instant t2 is equal to 5 seconds. So it's given by the square root of minus 10 multiplied by 5 minus 15 to the power 2 plus minus 8, 5 plus 16 to the power 2, which is equal to, plugging this on the calculator, then it's given by approximately 69.3 meters per second, As for the acceleration a2 corresponding for a computed at the instant t2 is equal to 5 seconds, and this is independent of time, which is given by 2 radical 41 meters per second square. Now for exercise number 17, they are telling me the parametric equations of a moving particle m in an xy plane are given by x of t and y of t. In number 1, we are asked to write the position vector, which is given by r is equal to 5t plus tan I plus minus 4t plus 16 j. Because the position vector r is equal to xi plus yj. Now as for number 2, they are telling me to determine the trajectory equation that dictates the motion of m. So x is equal to 5t plus tan, y is equal to minus 4t plus 16, and the trajectory equation is an equation that relates x and y and is independent of time. So we need to substitute by time or eliminate time, and this can be done by considering the linear term. Since x and y are linear in time, so we can consider either x or y. So let's for example consider y. So in this case, t is equal to y plus 4 divided by 16. Replace t is equal to y plus 4 divided by 16. In x, we got that x is equal to 5 multiplied by y plus 4, 16 plus tan. Notice that linear in one variable and linear in the other, or linear in two variables, then the trajectory is a straight line. The slope and the y-intercept of this line can be determined by writing this equation in the form of y is equal to ax plus b. Then a represents the slope and b represents the y-intercept. Now in number 3, they are telling me to determine the velocity vector. So in order to determine the velocity vector, we need to study the motion along the x-axis and along the y-axis separately. So let me list here on the scratch the equations of motion related to rectilinear motion, which is given by URM and VRM. So URM is given by x is equal to vt plus x0, v is equal to a constant, and the acceleration is equal to 0. As for UVRM, it's given by x is equal to half at square plus v0t plus x0. V is equal to at plus v0, and the acceleration is equal to a constant. And here we always have an additional equation, which is given by v square f minus v square I is equal to ad. Now let's study first the motion along the x-axis. So notice that the position along the x-axis is linear in time. Linear in time means that the type of motion is URM, and this occurs along the x-axis. Since x is equal to 5t plus tan verifies the general form x is equal to vt plus x0 here, because the motion occurs in 2 dimensions, then each component must be distinguished between x and y, in particular the speed here. Then the type of motion along the x-axis is URM. And now, because we have identified the type of motion along the x-axis, we can list the different equations of motions that are given by x is equal to vxt plus x0, in which that vx is equal to a constant and the acceleration along the x-axis is 0. The given form is given by x is equal to 5t plus tan. So by comparison, notice that we are interested in determining the velocity vector. The velocity vector v is given by vxi plus vyj. Let's start by determining vx. So comparing linear terms in the position, we get that vx is equal to 5 meters per second. So this is it for the motion along the x-axis. Now as for the y-axis, since y, which is given by minus 40 plus 16, verifies the general form. So notice that here y is linear in time, and linear in time means it's URM. Verifies the general form, y is equal to v0 yt plus y0. Then the type of motion, along the y-axis is URM, and by this now we can use the following equations that are given by y is equal to v0 vyt plus y0, vy is equal to a constant, and ay is equal to 0. Knowing that the given form is given by y is equal to 40 plus 16. So by comparison, we are interested in determining Vy in order to determine V. So Vy is equal to minus 4 meters per second, and eventually in this case the position vector V is time independent, and it's given by 5i minus 4g. Now they are telling me to deduce at any instant the speed v of the particle m, and by deduce it means that we need to use the previous part. In the previous part we have determined the vector v, which is the velocity, and this consists of 4 properties: point of application, line of action, direction, and magnitude. The magnitude stands for v without a vector, and this represents the speed. The magnitude of any vector can be written as vx square plus vy square, which is equal to square root of 5 square plus minus 4 to the power 2. Plugging this on the calculator, then the speed is given by square root of 41. Since everything is expressed in this I as written here, then v is equal to square root of 41 meter per second. So v is equal to square root of 41 meter per second, and square root of 41 in the decimal is given by almost 6.4 meters per second. Now in part 4 they are telling me to determine the acceleration vector. So now since we have studied the type of motions along the x and along the y, we can directly determine a, which is given by ax I plus ayj. Notice that in both cases the x and the y component of the acceleration is given by 0. So this is 0i plus 0j, which is equal to 0. Since this is a vectorial equation, we need to equate between vectors, so this is simply the 0 vector. Then the acceleration is equal to the 0 vector. Now in the same part they are telling me to deduce at any instant t the magnitude of the acceleration. We know that this acceleration vector has 4 properties given by point of application, line of action, direction, the magnitude. The magnitude a is simply given by square root of ax square plus ay square. Since the vector is 0 as a vector, so we expect that the magnitude is 0. You can check that a of x is 0 and a of y is 0, then a is given by 0. So the acceleration is 0, and here no need to specify a unit because anything multiplied by 0 is 0. Now in part 5 they are telling me to calculate at the instance t1 is equal to 2 seconds and t2 is equal to 5 seconds the speed and the magnitude of the acceleration. Great, so part 5, let's start by the instant t1 is equal to 2 seconds. So notice that v1, which is equal to v computed as t is equal to 2 seconds. Recall that v is independent of time, so this is given by square root of 41 meter per second. As for the acceleration, a1 computed at the instant t is equal to 2 seconds. This is also given by 0 because time independent. Now as for t2 is equal to 5 seconds, v2 computed at the instant t2 is equal to 5 seconds is given by square root of 41 meter per second because this is time independent, and a2, which stands for the acceleration computed at the instant t2 is equal to 5 seconds, is equal to 0 since this is time independent. So that's it for me in this video, guys. In the next part we'll complete the explanation of this chapter.